be talking about is exponential smoothing. So exponential smoothing is a technique used for time series data using the exponential window function. And so basically what we're going to do is we're going to write a program in Python about how to do simple exponential smoothing of sales data with trend and noise. So the first thing that we need to do is we need to import 4 libraries that are going to enable us to execute the program in Python. So the first library that we're going to import is NumPy as NP, which is the numeric library. And then we're going to import pandas as PD, which is a data processing library that creates the data frames. We're going to import matplotlib.pyplot as PLT, which is the visualization library. And from statsmodels TSA Holt Winters, we're going to import simple exponential smoothing. So that's what we're going to do in this instance. We're going to carry out simple exponential smoothing. Now, statsmodels is Python's statistical library, and TSA is the module within statsmodels that governs time series analysis. And Holt Winters is a specific algorithm for time series analysis, and simple exponential smoothing is a function within Holt Winters, and that's what we're going to be using. So what we want to do is we want to generate some synthetic sales data with trend and noise, and the first thing that we're going to do in that regard is we are going to set the seed. And then when we set the seed, what that does is every time you run the program, it initializes the data to the same values. So we're going to set the seed by typing np.random.seed, and you can type whatever number you want within the brackets. And days equals np.arange, brackets 1, 101. So that's going to give you 100 days of sales data. Trend equals 50 plus 0.5 times days. So it's going to give you a linear upward trend. Noise equals np.random.normal, and normal is a normal distribution, brackets 0, 5, blend days. So 0 is your mean, 5 is your standard deviation, and 100 is the length of the sample size. And that's going to generate your random noise. And sales data equals trend plus noise. So now what we're going to do is we're going to use pandas to create a data frame of the sales data. So sales df equals pd.dataframe, brackets, and then curly brackets, day colon days, sales colon sales data. So the first column is going to be day, and then the second column is going to be sales. And then in sales df.set index day in place equals true. So what that means is you're going to set the index to the day. So the day is going to be your index, and sales is going to be your data. So now what we're going to do is we're going to apply exponential smoothing. So smoothing model equals simple exponential smoothing, bracket sales df, square bracket sales, brackets dot fit, bracket smoothing level equals 0.2, optimize equals false. And then that means alpha equals 0.2. And smoothed sales equals smoothing model dot fitted values. So we're going to plot this data onto a chart, onto a graph. So plt.figure, brackets fixed size equals 6,5, plt.plot sales, brackets sales df dot index, sales df, square brackets sales, square brackets, label equals observed sales raw data, color equals blue, alpha equals 0.6. and plt.plot brackets cells df.index, comma, smooth cells, comma, label equals smooth cells, exponential smoothing, color equals red. So now we're going to add labels, title, and legend to the graph. So the title is exponential smoothing on sales data. The X label is day. The Y date label is sales. You get a legend, you get a grid, and we're going to show it. So this is your simple exponential smoothing. So the blue is the observed cells for raw data, and that's what we synthetically created, and you can see that it has a mild upward trend. And then the red is the exponential smoothing. And so the great thing is that statsmodels does that for you already. Statsmodels smooths the data for you already, but I do think that we did actually do an exponential smoothing using just NumPy and Pandas, but you can do it in statsmodels already. So that concludes this video. In the next video, we will be talking about some more time series subjects. So I hope you decide to watch them.